Here we're told that cautious consumers are sometimes worried about having their credit card, which has a total of 16 digits, um, being to be exposed in the form of a receipt lying around. In fact, I was one of these people who would always worry that, oh no, I have to shred this receipt because people will be able to find out my credit card number, and not thinking probably made this a little bit more irrational than it needed to be. So the first question asks, first, how many different credit card numbers are possible with 16 digits? So we have a total of 16 digits. 1, 2, 3, 4, 5, 6, all the way up to 16. So we have 1, 2, 3, 4, 5, 6, and then all the way up to 16. And now we just have to really consider how many possibilities there are for each digit. Well, this first digit, well, there are a total of 10 digits, 0 through 9, and so that means that for the first number there could be 10 possible digits, assuming there's no beginning preference, and assuming that the bank doesn't do anything different. It would be fair to say that there are about 10 digits. Now that should be the same for every single other number, right? Because 0 through 9 are still possible. Repeats are always allowed. Okay, so that means, well, let's see how many, so I'm going to have 10 here. I have to cross that with 10 over here, so that's going to give me a total of 100 digits. Get the 1 with the 1, the 1 with the 2, the 1 with the 3, the 1 with the 4, the 1 with the 5, 1 with the 6, etc. There's so many different combinations here that really this times this times this times this is going to be 10 to the 16th power, a really large number, which we're not going to write out because it's just going to end up having a lot of zeros, 16 specifically. So that's basically part A. The second question asks, how many different credit card numbers can be arranged with 6781 as the last 4 digits? Okay, so we have still ... all the way up until the 12th digit. And all of these numbers can be whatever they want. Our question is, if we have 13, 14, 15, and 16, the 13th, 14th, 15th, and 16th digits fixed, that means there's only one possibility for 13. That is, it's a 6. There's only one possibility for a 14. That is, it's a 7. One possibility here, one possibility here. Well, how many possibilities are there for the first 12 digits? Well, 10 for the first, it could be 0 through 9. 10 for the second, it could be 0 through 9. 10 for the third, 10 for the fourth, etc., all the way, or 10 to the 12th, for the 12th. Okay, well, how many 10s are we going to multiply together before we get to the 1s? There's going to be a total of 12 of them. So we're going to have 10 to the 12th possibilities for having 6781 as the last 4 digits. So obviously you can see right away that that's a huge number of possible digits that can have 6,781. The question is, on any one guess by a potential thief, what is the probability that he correctly guesses this person's credit card number? Okay, well, remember, probability, kind of going back to the definition, is the probability of a specific 16-digit number. Well, there's only one possibility for your credit card number, and that is exactly whatever your 16 digits are. Now, given that the potential thief, I suppose we should assume that that potential thief has picked up one of your receipts, maybe, and we want to know what's the probability that he would correctly be able to guess the remaining, or the previous 12 digits. Well, in that case, if he knew only the last 4, then there are 10 to the 12th total possibilities for total 16-digit numbers that are now included, given that he already knows the last 4. Well, 1 divided by 10 to the 12th is basically 1 times 10 to the negative 12th, which is, if you actually write this out, this is 11 zeros, ... 11 zeros, and then a 1. Now, that is a very, very small chance. That's effectively a 0% chance. It's getting kind of sloppy here. So 0% chance is really our answer here. There's almost no chance that he could guess it. Now, is that probability higher than if he didn't know any of those digits and was just randomly guessing? Well, yeah, it is, but not really by any significant amount, because this is already nearly impossible and would require many, many years for him to be able to go through every single possible combination before guessing the right one. And by that time, he'd probably have gotten into some trouble. So I guess the answer here in part C is, well, if we assume he knows the last 4 digits, then there's a 0% chance. But if you don't assume that he knows any of the digits, it's still a 0% chance.